Good evening, everybody. My name is Mohith, and today we are going to discuss the concept Ohm's law. So first, let us look at the statement. Ohm's law states that current through conductor between 2 points is directly proportional to the voltage across the 2 points. To visualize the Ohm's law, let us consider a conductor which is in cylindrical shape. So a conductor is a material or an object which allows free flow of electrons. So let us consider this cylinder of length L. Here the current through the conductor between 2 points, that is the point, let us consider this is point 1 and point 2, which is the two ends of the conductor. So current through the conductor between 2 points is directly proportional to the voltage across the 2 points. So here we are given that current, which is voltage, directly proportional to I, right? So to remove this proportionality symbol, we are introducing a constant which is resistance. So V is equal to Ri. So this is what here. So if we write the Ohm's law in algebraic form, which it is given as V is equal to IR, where V is the voltage, I is the current,
that is the potential difference. Its unit is volt.
Yes. And R is the resistance.
What is the unit of current?
Unit of current is ampere.
Resistance?
Resistance is ohms.
Oh.
So there is another formula for V which is equal to current rho length divided by area. We will derive this formula soon. Then we will look at the Ohm's law triangle. This triangle is used to rearrange the...
what is that, a rho?
Rho is the resistivity.
Very good.
So here we are using the Ohm's law triangle to rearrange the formula V is equal to. Suppose let's say that I have to find V. What you have to do is close the V and the remaining 2, which is I, into R. So this is the general formula. Let's say that I need current. So what we have to do is close the I, which means V by R. So suppose you have to find I means it's V by R. In the same case of R, it is V by I. Now the dimensional formula of Ohm's law is given as m L square T power minus 3 and A power minus 2, and the SI unit of Ohm's law is Ohm, which is given by omega, the symbol of
What does m represent?
M is meter.
Meter.
Meter, length,
L?
time.
No,
Then
m represents what?
M represents the
Mass.
mass.
L represents the length.
T is time, A is ampere. Now let's look at the dependence of R. So suppose let's take a conductor. Here we have taken a cuboid shaped conductor and we are placing it side by side or like adjacent to each other. So now the length is the length of one conductor is given as L and the another conductor also same L. As both the conductor are of same material, they both have the same voltage, which is V1 and V2. Here are V. Now if we take in resistance in combination, it will be like RC is equal to V plus V divided by I, which is equal to 2V by I. We know that from Ohm's law, we know that V by I is equal to R. We can find out using the Ohm's law triangle. V is equal to IR, like. So it is given at 2 into R. With this we can say that R is directly proportional to L.
You can mention the title as, instead of saying dependence of R, you can say that is influencing factors of resistance.
Okay.
Or factors influencing resistance. So likewise you can put.
So these are factors influencing. The next factor is that, suppose let's take a conductor with length L. Now we are dividing the area of the conductor by 2 so that it forms 2 conductors on top of each other, where the area of one conductor is A by 2. So applying it in the same formula, here the current is reduced as the area of the conductor is reduced. So R L is equal to V by I by 2, as the current has been reduced by twice. If we take the 2 to the top, we will get 2 into V by I, which is equal to 2R, as we know from the Ohm's law. So with this we can say that R is directly proportional to inverse of the area, that is 1 by A. So from the first and the second equation we can say that R is directly proportional to L by A. So removing the proportionality symbol, we are introducing a constant which is rho, which is known as resistivity. Now let us look at the difference between the resistance and resistivity. Resistance is the measure of opposition to the flow of electric current. Now resistivity is the property of the material by which it resists the amount of current. Resistance depends upon the length, area and the physical conditions, whereas resistivity depends upon the nature of the material. The SI unit of resistance is ohm and the SI unit of resistivity is ohm meter. Resistance is an extensive property and resistivity is an intensive property. Now let us look at the concept current density. The current per unit area, that is current by area, that I by A, is called the current density. The SI unit of current density is ampere per meter square. So we know that from the previous formula, that is V is equal to I rho L by A. We are substituting, instead of I by A, we are considering it as J, which is the current density. So instead of V, we are taking current into length. EL is equal to J rho L. When taking the L to the opposite side, it is E is equal to J by J rho. When we write this in the vector form,
the L is cancelled here.
Yes, the L is cancelled. Then we will get the formula E is equal to J rho.
What is J?
J is the current density.
Rho?
Rho is the resistivity.
Resistivity can also be called specific resistance.
So here, when we write this in the vector form, we will write E vector is equal to J rho. J and E are J vector rho. Or we can rearrange this and write as J vector is equal to surface density into E vector. As we know that 1 by rho is equivalent to...
that is conductivity. The sigma is called the reciprocal of rho.
Reciprocal.
So the reciprocal of rho. Rho is as resistivity. Reciprocal of resistivity is conductivity.
Okay,
so sigma is conductivity. That is specific conductance. Right?